Hi, ready to solve some equations? So here we're going to be solving equations that contain rational expressions. And when an equation has fractional expressions in it, that kind of makes it kind of complicated. So I'm going to show you how you can eliminate the fractions, get them out of the way, and turn your equation into one that doesn't have any of those fractions or rational expressions. And then you can just go ahead and solve it. And the trick is based on the fact that you are allowed to take any equation and multiply both sides by the same thing. If two things were originally equal to one another, then multiplying them both by the same number gives you things that are still equal. So here is the strategy for solving equations that involve fractions. If there's just one fraction, look at what it has in the denominator. If there's more than one fraction, look at the lowest common denominator of all the fractions. That is, the smallest or least complicated thing that is divisible by each of those individual denominators. So once you've figured out what that is, multiply everything on both sides of the equation by this lowest common denominator. And then simplify. And you should be able to eliminate all the fractions. Because remember, when you multiply a number times something over that number, any number divided by itself is just 1. So any number times something divided by that number is just the something. So that allows you to eliminate the denominators. Then you can solve the resulting equation. And one thing to watch out for is it could happen that when you do this, the solution you end up with might not really work in the original equation because it might give you a 0 in the denominator. So that's something you do need to check. Check any solution in the original equation just to see if it would give you a 0 in any of the denominators. And if that happens, you got to throw it out. It's what's called an extraneous solution. So let's look at some examples. X over 10 minus 2 equals 5. I only see one fraction here, and the denominator of this fraction is 10. So let's just multiply both sides of this equation by 10. 10 times the left side equals 10 times the right side. And remember, multiplication distributes over subtraction. So the 10 is getting multiplied by each of these two terms. We're doing 10 times x over 10 minus 10 times 2. And then that's equal to 10 times 5. But here, 10 times x over 10, the 10 over 10 cancels out, and all that's left there is an x. 10 times x divided by 10, the 10 divided by 10 is just 1. And then 1 times x is just x. So what we have now is no more fractions, just an x minus 10 times 2 is 20 equals 10 times 5 is 50. And we can certainly solve that. There's just one more thing we have to do. Add 20 to both sides, and we get x equals 70. So if you wanted to check that, if we put 70 in for x, 70 over 10 would be 7, and 7 minus 2 would equal 5. It works. Try this one. X over 3 plus 1 over 2 equals 7 over 6. Okay, here there's more than one fraction involved. They have denominators of 3 and 2 and 6. But what's the lowest common denominator? What's the lowest thing that is divisible by 3 and by 2 and by 6? Well, how about 6 itself? You can do 6 divided by 3, you can do 6 divided by 2, you can do 6 divided by 6. So I'm multiplying both sides by 6. That means each term gets multiplied by 6. 6 times x over 3 plus 6 times 1/2 equals 6 times 7/6. And 6 divided by 3 would be 2. And then 2 times this x would give you 2x. So 6x over 3. 6 times x over 3 simplifies to just 2x. No more fractions, because the 6 divided by the 3 is just a 2. And then here, this 6 divided by this 2 would be a 3. And this 6 divided by a 6 would be 1. So what we have now is no more fractions, just 2x plus 3 times 1 equals 1 times 7. 2x plus 3 equals 7. Now to finish solving that, what do we do next? Subtract 3 on both sides. So 2x equals 4. And what do we do next? To get from 2x to just x, divide both sides by 2. So x equals 2. And it really is true that 2/3 plus 1/2 equals 7/6. Okay, 8 minus x minus 2 over 2 equals x over 4. Look at the denominators. There's a 2 and a 4. What's the lowest common denominator? If you said 8, that is a common denominator. It is a multiple of 2 and of 4, but it's not the lowest. The lowest common denominator is actually 4. So I'm going to multiply both sides of this equation by 4. So we have to take 4 times 8 minus 4 times x minus 2 over 2 equals 4 times x over 4. That's going to allow us to cancel some fractions. There's no fractions here, so this would just be 4 times 8, those two numbers multiplied together. But here, this 4 divided by this 2, 4 over 2 is 2. And in this fractional situation, this 4 over this 4, 4 divided by 4, would just be 1. So we have 4 times 8 minus 2 times x minus 2 equals 1 times x. Multiplying things out, that's 32 minus 2x plus 4 equals x. I see like terms that I can combine. The 32 and the 4 already on the same side combine to 36. So it's 36 minus 2x equals x. Now I want one side to just be an x term and the other side to just be a constant term. And I think the easiest way to accomplish that would be to add plus 2x to both sides. So then 36 equals 3x. And now we want to end up with just plain old x equal to a number. So to go from 3x to x, divide by 3 on both sides, and we get x equals 12. So that is the solution. If you want to check it, it really does work, because if we put 12 in for x, 12 minus 2 would be 10. 10 divided by 2 is 5, and 8 minus 5 is 3. So the left side evaluates to 3. Meanwhile, the right side, if we put 12 in for x over there, 12 over 4 is also 3. So the two sides are equal. Let's try this one. Negative 8 over 3 minus 5x equals 4. There's only one fraction. The denominator of that fraction is the expression 3 minus 5x. So that's what I'm going to multiply by on both sides of this equation. 3 minus 5x times negative 8 over 3 minus 5x equals 3 minus 5x times 4. On the left, the 3 minus 5x divided by 3 minus 5x is just 1. And 1 times negative 8 is negative 8. On the other side, nothing divides out. It's just a 4 times a 3 minus 5x. And then when you multiply that through, you get 12 minus 20x. Then to finish this, subtract 12 on both sides. Negative 20 equals negative 20x. Divide both sides by negative 20, x equals 1, and there's the solution. Try this one. 3x minus 5 over x minus 1 equals 2 minus 2x over x minus 1. I see two fractional expressions, but they both have the same denominator, x minus 1. So that would be the common denominator, and that's what I want to multiply by on both sides of this equation. So x minus 1 times the left side equals x minus 1 times the right side. So over on the left, we got x minus 1 over x minus 1, which is just 1, times 3x minus 5. On the right side, we got x minus 1 times 2. Nothing cancels there. We just have to multiply those. Minus x minus 1 times 2x over x minus 1. And on there, the x minus 1 over x minus 1 divides out, and we just have the 2x. Now, no more fractions. Just continue solving. Distribute here to multiply out the parentheses. 3x minus 5 equals 2x minus 2 minus x. If I combine the x terms here, 2x minus 2x is 0x, or just 0, so those cancel out. 3x minus 5 equals negative 2. Add 5 to both sides, we get 3x equals 3. Divide both sides by 3, we get x equals 1. But wait a minute. If we go back and put in 1 for x in the original equation, look what we get. 3 times 1 is 3 minus 5 is negative 2 over 1 minus 1 is 0 equals 2 minus 2 over 0. Wait a minute. You can't have it like a negative 2 over 0. That's a division by 0 error. So 1 is not really a solution to this equation. If we try to put 1 in place of x, the two sides don't evaluate to the same number because they don't really evaluate at all. We just get a division by 0 error. So that's an example of an extraneous solution. That's why we have to, once we get what we think is a solution, we have to check and make sure that it doesn't give us a 0 in the denominator. Okay, one more example. 1 over x minus 2 minus 2 over x plus 3 equals 11 over x squared plus x minus 6. What's the lowest common denominator of all of these fractions? Well, that would be easier to see if this denominator were factored. Can you see how to factor that? Pause the video if you want to take the time to work it out. It factors into x plus 3 times x minus 2. So if we want something that's divisible by all three of these denominators, we can just use x plus 3 times x minus 2. So that's what I'm multiplying by on both sides of this equation. So when I take x plus 3 times x minus 2 times 1 over x minus 2, the x minus 2 over x minus 2 cancels, and I have the 1 times the x plus 3. Minus, when I take x plus 3 times x minus 2 times 2 over x plus 3, the x plus 3 over x plus 3 cancels, and I'm left with the minus 2 times x minus 2. On the other side, both factors cancel. The x plus 3, x minus 2, that whole thing divides by itself and leaves me with just 11. Now, multiply out to get rid of the parentheses, and we get 1x plus 3 minus 2x plus 4, because a minus 2 times a minus 2 is plus 4, equals 11. Combine like terms. X minus 2x is negative x, plus 3 plus 4 is plus 7, so that's equal to 11. Get rid of the plus 7 by subtracting 7 on both sides, so negative x equals 4. And to go from negative x to x, divide both sides by negative 1, and we get x equals negative 4. So that's the solution, I think, but we better check. Does it give us a 0 in any of these denominators? If I put in -4 for x, does that make any of these denominators 0? No. So we're good.